Hi there, welcome back. And this looks like a rat's nest. That's what prototyping is all about. This is a continuation on the video on the BFO to decode SSB communications on ham amateur radio. And I want to use it primarily on the satellite 2100, which I restored, and which actually has a BFO unit called the Zusatz 2000. But I originally thought of building that, but I decided to look for a different circuit with modern components that are more easily available. And perhaps anyone who wants to will be able to build it as well. But before I get into that, there were a lot of comments. I was getting that really ugly waveform, and I took some of the advice in the comments, did a lot of experimentation. As you can see, the board has suffered from it. But I've got to tell you, this board holds up well. Not one solder pad has been lifted. No shorts have happened. The solder masks held on well, so PCBWay is responsible for that, and they're sponsoring this video as well. Let me show you what the result of all this experimentation is. This is what the waveform looks like now on the output. And if I turn the pot to maximum, that's what I'm getting. It's a beautiful, beautiful sine wave. It is slightly distorted. You can see the upper half is slightly wider than the lower half, so it's not a pure sine wave, but it's bloody nice. And I'm getting about 980 millivolts RMS on that one. The other thing I did is I actually designed this thing to work with a 9-volt battery. And let me show you what the result is. I'm going to change the supply voltage to 9 volts. And look what happens. 11, 10, 9, 8, 7, 6. That's getting a bit small. But I can still use it. And the idea is I'm going to go back up to 9. The idea is to use a 9-volt battery if you want to, and get a perfectly usable wave. 800 millivolts is very, very good. And I can actually get a higher voltage than that. On the board, they tell us is actually, or on the schematic, they tell us is actually a second high voltage output. And that one comes straight from that transistor. So what I've done is I've got a wire coming to there. This is the cap that couples to the volume pot. So it's receiving from that end, the original, from the secondary of that IF transformer. But if I just lift this cap and touch it to there, I'll show you what the result is. I'm giving it 9 volts first of all. First thing you see is that the amplitude is way up there. Bring that down. But what you do see is you get 3.87, 3.9 volts. Again, a very clean sine wave. And that is the high level. And what I've done is I've decided to make the board selectable. You'll have a choice between the low level and the high level, so that we can then use that whichever way we want. So there we go, 3.9 volts. Now I'm going to change that to 12 volts. It's at 9 at the moment. And again, the amplitude goes up slightly to about 4.5 volts. It is starting to clip. If I give it 15, for example, actually, you don't see that much difference. That's 15 volts. But if you come down to 12, very clean sine wave, about 4.6 volts RMS. Now let's see the frequency stability. I'm going to put it back to the low one, and I'll show you the frequency. So here we have it set to approximately 460. This thing is varying slightly on the last digit. That is for two reasons. One, it is sitting literally in the open. There is no shielding whatsoever. Two, I've just switched this on again, and these capacitors are not NP0 or C0G caps. These capacitors are just normal capacitors. So when I get the proper ones, that's what we'll be using. But what I want to show you is this. There's the low end, 457.75. That is 2.25 kilohertz on the low end. And if I move it to the top, 462.05. I'm getting about 2.3 kilohertz span. I can increase that or decrease that. I'm just changing that. And I'm happy with the span because, hey, it's working. So what I'm going to do is show you, I'm going to just place the order, and when that comes in, we'll see the final result, the build, and boxing, and the final test of this thing. I've got another surprise coming up, but I'm just going to tell you it's there. I'm not going to tell you what it is, because I decided to actually do a slightly different version of this, which, well, I don't know how many of you will be interested in that, but let's carry on. So here's the circuit that's resulted from a lot of the advice that I got from the comments. Let's start here. What we have here is the normal situation. I changed the coupling capacitor value between the varicap and the actual other capacitor, because this is forming a tuned circuit, tank circuit, this inductor here between pin 2 and 3. And this capacitor, that's the stable tank circuit, and then you're adding capacitance from the varicap, which is determined by the amount of voltage that you actually apply to it. So when you've got 0 voltage, it's got maximum capacitance. When you've got the maximum voltage, it drops the capacitance. So that's how you tune the circuit. So not much has changed here except that value over there. This stays the same. That resistor may be removed, but it's in at the moment because it depends on which varicap you use, and depending on which varicap you use, you can adjust the maximum voltage to which you can tune it to. You've got a voltage over here which is set by that Zener, and I'll get to that in a second, and that voltage can go straight across the tuning variable resistor, which means you can tune from 0 volts to 6.8 in this case, or you have a voltage drop because that 339K will act as a dropper to give you less range on this one. So that can be adjusted depending on the varicap. Other than that, that stays the same. I had a problem with the biasing, as you probably noticed. This 33K and this 15K set a voltage across here. That'll change obviously because I've dropped the voltage here, but I'll show you what the result was. That'll change. That sets a voltage. That creates a voltage there of 0.6 or 0.7 volts below that, which creates a current across that 1K resistor. That stayed the same. That stays the same. That stays the same. Now, I actually got a tuning capacitor from an old radio. Each half of it was about 500 picofarads. I put them in parallel. So I could actually have a variable capacitor from 0 to 1 nanofarad, 1000 picofarads. And that was very useful to see which of these capacitors actually made the most difference, and I found that it didn't really. So what I've done to resolve the biasing issue here, which is basically the secret of this change, is I've put a 47K trimmer. And that 47K trimmer, it's a 10-turn pot that I have here. And that is used instead of those resistors. Now, I've put them both in here. You can see it's basically doing the same thing. It's taking between the top, the supply and ground, and the wiper goes to the middle, and it's the same as that. You've basically got two resistors being created by that pot. Now, you can either use the two fixed resistors or the pot, or you can set the value as you want it with the pot and then remove it, and see what resistance values you have between the wiper in the top and wiper in the bottom, and put fixed resistors in there. So I've left both options on the board. I've dropped this to 6.8 volt Zener for the simple reason that I want this thing to operate with a 9 volt battery as well. It is set to 12 volt supply, as you can see up here. That's the normal 12 volt supply, but I wanted it to be able to work down to a battery. So all the tuning here was done with 6.8 volt on that rail. Then here nothing changes. Basically that's the same. I've put in a 100 microfarad electrolytic here as well, because depending on where the source is from, I'm not sure how clean that supply is going to be. So I thought I'd put that in just in case we need some more filtering. Over here the same thing happens. You've got the bias resistors. Those made no difference no matter what I did to them. That 270 made no difference. That then is the IF transformer for the output. The signals created with the primary as the load, as the collector load. And then, of course, the secondary brings us the brings us the output. There is a mistake here. That's 390 ohms, not 3.3K. That's the 390 ohms. Got to change that. Done. 390 ohms, fixed load, and then that takes your signal from there. That part is grounded from there to that output there. Now, why do I have this here? Well, this is a header with 3 pins. The low output, which is the normal output, comes to that pin 3. There is also an alternative for a higher output, which is from the collector. That goes straight to pin 1. And then depending on which 2 you short, and you can do it with those little shorting tabs, you decide which level you want to take to your pot. And that goes through the 100 nanofarad capacitor to a variable resistor to a pot, and that's your RF out. There's also an RF ground out. So this is the circuit that I'm considering, quote unquote, the final circuit. And this is what the board looks like. And what I've done is I've decided to make it all through hole. All these components are through hole. And the reason is I did the previous one as a mixed version of surface mount and through hole. And I know, I was one of them, some people still don't like that. So I decided to do this all through hole. And I've optimized the layout as much as I can. I think I've taken fairly good care of it. I've also done something like changing the actual component pad sizes to make it more solder friendly. And what we have here really is the layout as symmetrical as can be, as I can make it. There's your RF out on headers. There is that 3-way header to select between those 2, which gives you high, or those 2, which gives you low. Your pot here, this is your tune pot. There's our little varicap. Again, everything is has been, well, I've tried to set everything up in a way that makes sense in terms of which is part of the circuit it relates to, and also trying to get the grounding system as carefully set as possible. The bias trim pot over here, it's actually in doing the same job as a few of these resistors. I think it's 5 and 6, if I'm not mistaken. Well, 2 of these resistors. No, it's, 5 and 6. If you use the trim pot, you don't use those 2 resistors. Or you can set the trim pot, adjust it, take it out, measure what values you want, and then you can put those as fixed resistors depending on the values you got from there. There are no components on the bottom side. There are a few traces on the bottom side, but other than that, it's a double-sided board, but most of the routing is on the top side, so it's easy to see. And that works out very well. I've got a board which is 49.53 millimeters high by 80 millimeters wide. It's as optimized as I can make it. I've got holes on there to put it down. I've got these pots equidistant from the ends. I've gone rather anal on this, I must admit. This thing is the sort of thing that can drive you nuts, and you can take forever and still not be happy with everything about it. I've called this one the BFO V2.0. Just a spoiler alert, there's a V2.1, and that's a surprise that you'll only get when I get the boards back. So what I'm going to do now is I'm going to create the Gerbers, and I won't publish these Gerbers yet because I'll do that after I receive the boards and test them, and then I'll make them available for you on PCBWay's project page, so you can just simply use them and build your own boards if you wish. And as I said, there'll be 2 boards, 2.0 and 2.1. 2.1 is the surprise. I'm sure you can guess what it is, but I'll leave it at that. And this is what the board looks like. You can see everything neatly laid out. All the labeling is done, trying to conform to a norm, just to try and make it neat, make it visible and understandable. I haven't put the values on here because I'm still not, I'm an optimist, but I'm not absolutely certain this is the final version. We shall see when I build it. So I referred to the schematic to get the values, and if I change that, I don't have to change the boards. So this is the top side, and this is the bottom side, where basically we have 3 traces. It's all a ground plane, lots of vias, lots and lots of vias, probably too many, but it's better to have too many than too few. So here we are on PCBWay's website, and I've logged in. I've got nothing in the cart at the moment. I've put in the dimensions for that board. It's 2-layer, 1.6 millimeter, quote now. And we see the pricing at $5 for 10 boards, as usual. All right, let's see what changes we can make on here. Let's see, different design panels. No, there's the size, that's fine. 10 pieces, it's 2-layer. I want FR4 boards, which is fine. Quite honestly, I don't even know what that means. Thickness 1.6 is fine. That's fine, I just leave that as standard. Now I'm going to go for blue this time. As you can see, it stays the same. You can do it in Express 48 hours, Express 24 hours. Price goes up somewhat, but I normally accept the 2 to 3 days. It's fine. More often than not, it comes out quicker than this. Okay. What else? Green would be the same. Just checking. Red would be the same. Yellow would be the same. Blue is the same. Or white. Or black. Right, blue it is. There are also other colors available. Silkscreen. White silkscreen on blue, yeah, that looks good. Black wouldn't be too good. So we'll leave that on there. What happens if I do that? Oh, okay. Gold fingers. Certainly takes the price up. Okay. HSL with lead, I prefer that. Soldering is perfect like that. Everything else I leave standard. Special requests, there aren't any. And I can add that to cart. Now, I've got a problem here in Portugal. My DHL is very, very expensive. If you do the normal postage, it comes out at $7. Certainly a lot different, but I prefer DHL. That's my choice. And anyway, I'm ordering more than one board. I'm only going to show you this one. You'll have to wait till I get the boards and I'll surprise you with the other one. So we're good. Save to cart. Now I've got to upload the file and it's Gerber's. It allows you a complete preview within 5 to 10 minutes. I'm just going to select the order. So it goes under review. I presume they do a little bit of checking, make sure that everything's okay. I get my order here. I can then get told later, I'll get a message saying I'm ready to pay for it because it has been accepted. It'll get to the awaiting payment section. And that's it. It then comes back and I'm ready to then show you what the result is. And that's it. Now, I'm not posting these Gerbers to the projects page. There's a project section here, which I've done with the last one. And I then provide a link in the description so that you can actually just use those Gerbers and make your own boards. I'll wait till I get it. I'll do another test. Call that the second prototype. I think I've covered everything. But once I know that it's working, I'll then provide the Gerbers for you. And you can do that yourself. And who knows, maybe you want to do version 2.1 when you see it. Or both. Why not? So, PCBWay, thanks very much for your support on this. I really appreciate it. The quality of the boards have been fantastic. No complaints whatsoever. The ease is something that I really like. The speed is also quite amazing. So if you've enjoyed that, please click share, like, subscribe and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Oh, it's just told me that it has been approved. See, there's the message coming back saying it's approved. I can then proceed with continuation of this. And no, I have not forgotten the GRUNDIG 4006. I am waiting for a spare front end for the FM, which, as I showed you, it was pretty damaged. I will be receiving that soon from a friend of mine in Germany. When I get that, I'll be making an attempt to repair the one that's there, but I want to make sure I've got a spare, just so that I don't have to stop the project again. See you back soon. Bye for now. Stay safe.